And we are immediately continuing with the next interesting topic. On stage, we'll be talking about the efficient protection of fuel cells with cathode air filters. An important topic, and talking about that will be the Adsorbent Specialist of Hengst. Can I get a warm applause for Dr. Niels Tannert?
Thank you for the warm welcome, and good morning, everybody. Welcome from my side here at the Hannover Fair. Here's the presentation. I'm coming from a filtration company from Germany called Hengst. We're in Westphalia, Münster, so quite clear nearby. And I would like to give some hopefully meaningful insights on the efficient protection of fuel cells with cathode air filters. First of all, I would like to introduce the company Hengst. We're a family-owned business in Münster, founded over 60 years ago, approximately more than 3,000 employees, and 22 different locations in 12 countries. And we're originating from the world of oil and fuel filtration, also air filtration. So basically anything from the vacuum cleaner, small filters, to quite complex oil modules equipped with heat exchangers, etc. We have quite a broad manufacturing capabilities, from die casting to plastic injection molding. So yes, really from the small filter element to much more complex assemblies, such as the fuel cell products, which I would like to highlight today. In this scope, we have three different applications running. One is the water separation on the anode side. So the hydrogen recirculation needs to assure that the water droplets on the anode side can be separated. This is doing the anode management module. We have some ion exchanger for the coolant filtration. So the coolant needs to be as conductive, as less conductive as possible. So therefore, we have some ion exchange module to reduce the conductivity. But today I would like to talk on the cathode air filter. So the supply of cathodes with air. And there we are facing some serious and interesting issues. This is due to the fact that the cathode needs to be protected from particles, bigger particles that you can see by eye, but also down to the size of gases. So we really need to assure that fuel cells are protected from particles and gases all along this spectrum. And this is quite some challenge because you will use different types of filtration techniques down to the adsorptive techniques where you're able to get rid of gases and vapors. And this is exactly what I would like to highlight in the next few minutes. So what is adsorption? Adsorption is the attachment of molecules to a surface. So it is not absorption when something gets dissolved or taken up by a media, but it is rather using a surface to attach molecules from the air to that surface. So what can you do with adsorption? You can, for example, remove gases and vapors like nitrous oxide, sulfur dioxide, or different volatile organic compounds to assure best air quality as possible. So, like I said, adsorption is directly connected to surface area. So therefore, you want to use some high surface area media. Now, how much surface area is there in 1 gram of adsorbents when we're talking about porous media? It is actually quite impressive how much surface area can be in 1 gram, which is something like some tiny little bulk of powder. And if you compare that, for example, to some basketball field, which has 400 square meters, or even some football field, there's some quite big surface area, but such adsorbent, such porous media can cover up thousands to multiple thousands of square meters in 1 gram. So the molecules can really go deep inside these structures and attach in their internal surface area. And this is exactly the mechanism that we are using here to get rid of gases and vapors by employing such porous media with ultra-high surface areas. Now, this is the range of adsorbents that we can apply. Activated carbons, most of you have seen that, applied that, but there's quite a bundle of others that we can apply. Now, which applications are we talking about? There are various applications. For today, like the title of my talk says, I would like to focus on the cathode air filtration, so getting rid of particles and gases and vapors in the fuel cell meaning. Now, why is that important? Fuel cells can really be harmed irreversibly by particles and chemical pollutants. For example, sulfurous species, but also volatile organic compounds, can poison the catalyst inside the fuel stacks irreversibly. Also the membranes inside the stacks and also the membranes inside the humidifier module can get poisoned and irreversible power loss will occur. And this, of course, is not, cannot be taken. So therefore, we need peak protection and long-term efficiency for various different species and pollutants. And yes, to show you quite impressively, we were quite satisfied to show that the right graph shows the cell voltage reduction in millivolts per hour when you do not protect your fuel cell with a fuel cell filter. And you can see that the fuel cell, the cell reduction of the potential increases with increasing amount for gases pollutants. And when you now equip a filter to your fuel cell system, you can reduce that to a minimum. So therefore, it is really highly recommended to protect fuel cells with cathode air filters, and this Hengst can supply you with. Now, where are the challenges? The challenges is that there are chemically very different pollutants. So more than 99.99% of the air that we breathe is just fine for the fuel cell. It is in the ppm to ppb range, so parts per million, parts per billion, the concentration range that can already harm the fuel cell. So 1/billionth part of the air is able to damage fuel cell, and therefore we have to take care that we weigh the filtration and adsorption against pressure drop, for example, and get a best as possible protection for fuel cells. If you imagine now that you have some filter element where the air passes only once, and you have contact times with the filter media, the adsorbents of only less than 1 second, and you want to get rid of each billionth of particle in such a short contact time, you can imagine on what's the challenge here to get rid of such low concentrations in such short times with so much surface area. We have various filter geometries. We need a reliable filter design process, including the performance prediction and end-of-lifetime prediction. So there's quite some engineering behind. There are multiple influencing factors on adsorption. So we need to really take into account all these influencing factors on adsorption, the influencing factors on filter design. So this is not some easy task to do here, but it's really multifaceted and quite some engineering task to get the best efficient protection of fuel cells as possible. Of course, you will also need to take into account real-life conditions, such as varying concentrations or driving cycles. All right, and in the end, you will have to measure that. Also, the low concentrations down to the ppb and ppm range, which is for the analytical part also a real challenge. Now, how do we do that? We go in our lab and we have different characterization techniques. For example, we can measure the uptake of our adsorbents, of the activated carbon media, of ion exchange media, of zeolites, of other adsorbents, to choose the best adsorbents that we have and to develop the best adsorbents that we have and combine the adsorbents for specific gases that we want to protect the fuel cell and the specific application from. We can also do some breakthrough experiments, so we flow through the filter the concentration enriched air, and we see on how much air is coming behind the filter, so how efficient is the protection. The development process is also multifaceted. It takes into account the external influencing factors such as temperature, humidity, concentration, but we also do CFD simulation at Hengst to have a look on the best pleating of the filter media and to get the best filter design. So there's really some work to do for our laboratory, for the engineers, and also for filter manufacturing. So in the end, we came up with a modular concept for the protection of cathode air fuel cell. There are some quite small filter elements, for example, for forklift applications and passenger car applications. There are bigger ones which you can have a look at our booth at D44, which is right behind here, D44. You will find some filters and some other applications which I said in the introduction. And there's also the possibility to align these filters in a modular approach to come to protect really bigger applications, up to stationary fuel cells. So it does not always have to be mobile. It can also be stationary protection, where you have really big filter elements to ensure safe and certain running of fuel cells of various kinds. So to sum that up, we're having lots of challenges to tackle when we want to protect the fuel cell as best and as long as possible. We have gases that would otherwise poison the fuel cell irreversibly, so I can really only recommend to protect your fuel cells as best as possible, also from the air path. In the end, we came up with a high-performance filtration and adsorption solution with a modular concept. And with this, I would like to close. If any questions occur, I will be glad to answer them. Right now, 1 more minute should be there. Otherwise, please visit us at booth D44 in this hall. Thanks for your attention.
Thank you, Dr. Niels Tannert. Perfect. Wonderful. And I would suggest to answer those questions maybe over here. Dr. Tannert will take up the microphone, so I'm sure he is able to answer some questions here. And otherwise, you can continue the conversation at booth D44-1, it was, right?
D44,
okay.
Exactly. Thank you.
Yeah, one more applause, please, for Dr. Niels Tannert.